2, 2. There's one. All the other ones got 2 or 3, right? There's one. See, look, it's kind of fun, like hunt and find. Seek and you shall find. Okay, now we'll go through and color. Oh boy, we're not much on colors here. How about orangish? This is vitamin D, so all the ones with 2 hydrogens will color kind of. Maybe we should color the methyls red. It's too late now, huh? We're experts. We're not going to get these mixed up. I just want to distinguish the different carbons here. So if there's 2 H's, it's going to get a reddish. 2 H's. 2 H's. 2 H's. 2 H's. I got 3 right in a row, huh? 2 H's. 2 H's. 3, 2. 2, 2, methyl, methyl, methyl. Let's see. Methyls, we'll just color methyls with the black marker, I guess, since a methyl's a methyl any way you look at it. There. 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 Now, any other carbons we haven't taken care of? What about this one? We'll just color them black since that's a hydroxyl. That's actually one you'd call a side group. Hydroxyl side group on it. So this is the vitamin B3. This is the active ingredient now. So I'm going to draw the ring again because over here we're going to head to what is called 25-hydroxy. 25. There's only one hydroxyl group, so that's why it's still getting that big long name. Number 25-hydroxy. Vitamin D3, Vit D3. So we're going to draw all that and stop the film to save time. Okay, this is another active form here. So let's get some of this out of the way. Keep all that on there. Is it going to fall over? Sure looks like it. 25-hydroxy vitamin B3. This is one of the active forms again. Okay. Let's get that on there so we can get this, huh? Most of the molecules there. So what we're going to go through with first, the carbons that got all 4 bonds. So right here, this carbon's got all 4. These we had to fix up. We did a goof. We even found the stickers in the garbage to cover these up with. These white things were on name tags that the church didn't finish using. So we'll put them to good use, fixing our mistakes. Here's 4 bonds on that carbon. Any other ones in here? Oh, there's one with the OH on it. That counts, huh? O is electronegative. Looks like all these are going to be hydrocarbon, not hydro, but just regular straight chain carbons through there, all the way down to there. Okay, let's add some H's on there. What do you think? Let's work around one at a time. 2, it's got the 4 bonds, 1 on the hydroxyl group. 2, 2, 2, 1, 1, 2, 2, 2, 3. This is a methyl. See that? These out here are methyls. 1, 2, 3. 1, Here's a methyl. 1, 2, 3. Now the methyls have to be hanging off, right? Because there's no way you can have 3 H's if it's carbon-carbon, because it's only got the 4 bonds. So 1, 1, 2, 1, 2. Here we go, exercising again. 1, 2. 1. I don't trust this. That's just 1. 1, 2. 1, 2. 1. Come around, get the marker for some of these here. Show up on the paper, eh? There you go. So all the H's are done. Now let's say, brown. What should we do? Brown we did before were all the 1s. So here's the 1. 1H is what we're looking for. Here's one since it's on the OH. See, this has an H. That one up there didn't, so that's a different carbon altogether. So all the ones with 1 hydrogen are what we're coloring brown here. And see, then we can compare it to the other one, and it shows us where the reactions were happening. There's 1. There's 1. All those got 2. There's a weird red one for the carbons with 2. So we look down here and compare. Rings look a little different. So we can fit both those into the picture here, on the bottom anyway. So, actually we should have done that one. Anyway, next to that was red. That to a black, but now that one's changed, huh? That one's got 2. That one's got 2, so that's still the same. Well, there's one with 1. See, we should have colored that brown. We were missing it already. So let's get down here and color this in, then you can compare it later. 2 right next to each other with 1. These are 2s, so color them in. 1, 2. Now remember, all this is from the steroid ring too, right? Oh, that's a 3. Okay, so 2, 2, 2, 2 H's, 2 H's, methyl, methyl. Okay, methyls actually get to be colored in with real marker also. So CH3s, CH3s, CH3s. That way you can still compare them. So look, there's 2 methyls and OH out there, so that knocked one of the methyls away. This just really makes it a lot easier to look at the molecule, I think. So now we're going to pause it and see if we can get the other one in there. Out of tape here, so we got her finished up here. 4 different steps that the vitamin D3 can go through. The ultraviolet light broke up the double bond. Now you get an O from the liver, so that makes the 25-hydroxy. They're counting this as the 25th carbon is now a diol, right? Well, now you get another O from the kidneys, which makes it a triol. So this ring, a lot of the stuff's happening in here. Then all of a sudden, when you think you got it down, it hydroxylates it out there. That's on the end. So the ring, I mean, now there's still the 5-membered ring and the 6-membered ring, but the 2 rings, I guess you still got a ring up there too. But boy, that sure opened up from the cholesterol ring that we had. See, that's still got the 4 rings in there, the big old cholesterol side group as usual. 1 little OH out there. So that's 7-dehydro, because it took the other OL off, cholesterol. UV light hits it, breaks open that middle ring, and it gets an O from the liver, goes to 25-hydroxy, vitamin D3.